Hey everyone, we're here in one of our last videos for the semester, and we're going to cover our last new material for the semester as well, and that's going to be on systems of inequalities. So I know in our last video we talked about system of equations. Here we're dealing with greater than or less than signs, greater than or equal to, less than or equal to signs, hopefully from piecewise functions and systems of equations. Some of this material should synthesize pretty well and make sense. But as we're going to be looking at inequalities and how to graph them and what systems of those are like, we're going to start to see on our graph some shading. So it might be best to start maybe with an example of type of inequality that we'll be looking at, and let's start with this. X is greater than or equal to 1. Now, if you're just going to graph x equals 1, for example, on some graph, right, that would just be a line. Anytime you have an equation, right, it's just a line. Any of these coordinate points up or down, x equals 1, right? 1 comma 0, 1 comma 1, 1 comma negative 1. X is always equal to 1 up and down vertically. It crosses the x-axis in this case. But if we're looking at numbers greater than or equal to 1, that could be a lot of different numbers, right? 2 is greater than 1. 10 is greater than 1. 1,000,000 is greater than 1. And 1 itself is greater than or equal to 1. So we're not just going to have a line. Now we're going to have some shading towards positive numbers, towards numbers that are greater than 1 or equal to it, as our problem says here. So whenever we have a greater than or equal to sign, we're shading towards positive numbers, and we have a solid line in this case, just like we have a solid line in our inequality. If we have a different example, for example, y is less than negative 1, okay, that line is going to cross the y-axis in this case, and it's going to be a dotted line because we're not equaling negative 1, right? We're having numbers that are just lower, like negative 2 or negative 1.1, negative 50, negative 1,000, okay? Those are all numbers that are less than negative 1. Negative 1 itself is not less than negative 1, so we do not have a solid line in this case. So if you don't have a solid line with your inequality, you don't have a solid line on the graph. You have shading, you don't have a solid line. If you do have a solid line in your inequality, you do have a solid line in your graph, as well as some shading. So it's the difference between a dashed versus a solid line. And then if you have something that's greater than or equal to, shade towards positive numbers, or as we'll see in later examples, shade above. If you have a less than or equal to sign, you're going to shade towards negative numbers or shade below. Okay. So we're going to keep that in mind as we start to look at systems of inequalities. So this is two or more inequalities that we're graphing at the same time. So here's an example. Y is less than or equal to negative 2x minus 1. Now, if you're just graphing a line or an equation, it would just be a line. Here we're going to have some shading though, okay? And in this case, we know that we're going to be shading below towards negative numbers, the line that will create, and that line will be solid, right? Shade below, solid red line. So, you know, our y-intercept will be negative 1. Our slope should be negative 2, so down by 2 over 1, down by 2 over 1, down by 2 over 1. Our slope is negative, so our line is decreasing over time. And we're shading everything below this red line. So you see the red here, and that would also be shaded in red. That's going to be mixed with blue in a minute, as we'll see. Okay. That's one of our inequalities. Now the other one that we would be looking at is 3x plus 4. So again, if that was an equation, we would just be graphing a line. It's not just an equation though, right? It is a greater than sign, so we're going to be shading above the line, and it's going to be dashed. Because there's no line here, there will be no solid line on our graph. It'll be a dashed line, and we're shading everything above, right, everything above that blue line, y-intercept of 4, slope is positive 3, it's increasing as you can see over time. Okay. And we're shading everything above that, so we'd be shading all of this area here. Now what you'll notice is that we have a purple region. That's an area of overlap, right? We said we're going to shade everything above blue and below red. So this has shading over both of our inequalities, and that is our what's called feasible region, or it's where our solutions are for the system. Okay, we're going to talk about that in a minute. But where you have shading, sometimes you have areas of overlap that we shade two inequalities at the same time. This is that area of overlap, and this would be the solutions to our system of inequalities. Okay. Now what do solutions look like? Okay. We'll come back and do another graphing example in a moment. But what do solutions look like very quickly? Okay. Well, we have some rules. Number one, coordinate points cannot be solutions if they're not found in purple space, or if they're not found on a solid line next to purple space. So, for example, let's start with 4 comma negative 1. So that means x comma y, right? Is this a solution to whatever we're graphing here, to this system of inequalities? Right? We have some shading. This is our area of overlap between the red and the blue inequalities that we would be creating, or matching with this graph. If we take a look at 4 comma negative 1, right, that's here. Okay? That's not anywhere close to where we have solutions. Solutions are all going to be found around this area. So no, this is not a solution to our system of inequalities. But 0 comma 3 on the other hand, x comma y, so don't go left or right, go straight up, right, here. That is found within our shaded region, our overlapping shaded region, in fact. So this is a solution. It's found in that purple space, or the darkest region on our graph that is shaded. Negative 1 comma 4. Now this is also a solution. It's in purple space. That's here, roughly. Okay, that's also a solution. 0 comma 1, okay, that would be here. We never have a solution on a dashed line. Okay, so anytime you see a dashed line and you have a coordinate point that falls on that, not a solution. Not to the system of inequalities that you're looking at anyway. 1 comma negative 2 would be on a solid line, but that solid line is not anywhere close to our shaded region. This is not correct. Okay, this is not a solution. 3 comma 0, okay, notice the difference here, right? X comma y. 3 comma 0 is along the x-axis. Again, that's not a solution. It's not near where our shaded region is. Negative 1 comma 1, okay, that's kind of at the crosshairs here of a solid line and a dotted line. Again, anytime you have a coordinate point on a dashed line, not a solution. Negative 2 comma 3. Now that actually falls on a solid line. Okay. And finally, this coordinate point is on a solid line next to shaded space. That is a solution. Okay. This is a solution. It's on a solid line. It's not on a dashed line. It is next to our overlapping shaded region. That is a solution. Okay. And lastly, 3 comma 4. Okay. That's clearly a solution. That's clearly inside of our purple region. Those would be solutions or examples of them from your system of inequalities graphed here. You could find a lot more solutions. In fact, you could find infinitely many. But these are just some examples. So remember, anytime you have something that falls in white space, not a solution. Anytime you have something that falls on a dashed line, not a solution. Anytime you have something that falls on a solid line, and it's not next to the shaded region, not a solution. But if you have coordinate points that are within that overlapping shaded region of your inequalities, or if they're on a solid line next to that, and they're not on a dashed line, those are solutions. So those are some examples. Let's go back to graphing now and take a look at a student who's tried to graph the following system of inequalities, right? We have two inequalities here. That means we're going to have two lines Both of them are going to involve shading, and then we're going to see what is or is not correct about what Jacinta has tried to graph here. So, number one. Well, we have two dashed lines here. So if they were both dashed, remember, that would mean either one of these two symbols should show up in her inequalities. In this case, though, one of those is a greater than or equal to, right? That means we should have a solid line somewhere, right? Solid line means solid line on the graph, and in fact, the red graph here, that should be a solid line. Solid red line, right? That slope is positive, crosses the y-axis at -3. That should be a solid line. That's one mistake that she made with her graph, okay? Should be a solid red line. Now the shading for that is okay. She shaded things that are above red, okay? That's fine, not really an issue, especially since, secondly, she should be shading below the blue line. Well, actually this is a mistake. Notice her shading is off. She thought that the overlapping shaded region was here, right? Above blue and above red. She thought that that would be where we have our shading over both regions. But that's not really true, right? This is telling us we should shade below. Okay, shade below. Now, she did create a dashed line, that's good. But we should be shading below the blue line. In other words, the real solution to this problem is not the purple. It would be this. Above red, below blue. Okay. All of this area would be the solution area to her problem. And as well as that, she needs a solid red line. So shading should be below. For a less than sign, we should be shading below the blue line. So, two mistakes that she made there. That covers graphing pretty in depth. You could easily find coordinate points now based on the actual area that should be shaded, not purple. The black region should be shaded. I do want to cover one more topic here, now that we've talked about graphing pretty extensively and coordinate points, and that is real world scenarios. Always want to try to connect this to where you could see this in the real world. So, systems of inequalities, we're going to look for some keywords here. We have a student or a person, Alexia, who's a salesperson at a car dealership. She makes a certain amount of money per hour, but also she gets commission, right? She makes $320 for every car that she sells. So, two things that she is having happen at once. But she needs to earn at least $2,300 per month. We're going to keep that in mind. And she needs to work at least 35 hours. Now those are key words there, right? We're going to come back and think about those as well. So if hours equals H and cars sold equals C, what system of inequalities would represent what we're seeing here? Okay, so let's think about that. Well, first of all, H. We know she needs to work at least 35 hours. Okay, 35 is the least. You can work 35, you can work equal to that, but you can't work anything less than that. Hours has to be greater than or equal to 35. Anything that you have here for hours, the least that it can be is 35. It can be 35, it can be 36, right? The least is 35. Okay, so greater than or equal to sign in this scenario because of this keyword. Cars sold, so C. Think about this. Can you sell negative cars? And I hope you realize that no, you cannot. You can sell 0 cars if you're having a bad month. You can sell positive cars. You can sell 1 or 3 or however many cars, but you can't sell negative. So that would be another inequality in your system. And then lastly, okay, I guess I can underline this as well since that would be a key word. $16 per hour, so 16 times H, and or plus $320 per car that she sells. Now that has to combine to equal something. And it's got to be at least, again, $2,300. So think back to what we just talked about, at least. All of this on the left side of the inequality has to be minimum $2,300 in order for her to pay expenses, rent, utilities, whatever, okay? This combined has to be at least this. Can't be anything less. So it can be equal to it, can't be less than that, it's got to be greater than or equal to. And that wraps up our discussion of systems of inequalities. That also wraps up everything I've got to teach for this semester, and it was really fun talking to you guys. Hope that this has helped, this entire series. If there are any questions that I have not covered and you would like me to, reach out, and I'll be happy to go over those with you. So study hard, guys. You'll do great, and I will see you in the future.